This topic will cover an overview of column hydraulic analysis for sizing and rating in Aspen Plus. Distillation columns are notorious for being difficult to operate, difficult to troubleshoot, or for being process bottlenecks. In addition, distillation columns typically consume approximately 40% of the total energy used in plant operation. There are several scenarios where column performance should be evaluated: increasing process capacity, reducing overall operating expense, evaluating a feedstock change, troubleshooting a problem, or evaluating a new design. At the same time, multiple facets such as the heat and material balance, thermodynamic limits, and hydraulic limits are involved to fully understand column operation and performance. Column performance is typically evaluated first based on thermodynamics. The next step is to understand the vapor and liquid traffic in the column as a result of the trays or packing. These internals put physical limits on the operation of the column. These limits can be exposed with plant disturbances or operational changes. Several different physical phenomena can occur outside of normal operation, such as weeping, jet flooding, downcomer flooding, excessive pressure drop, and others. So, fully understanding the column hydraulics can help address issues regarding limited capacity, excessive energy costs, or product quality issues. RadFrac is the main distillation unit operation in Aspen Plus, and it can be used to model a variety of systems: ordinary distillation, absorption, stripping, extractive and azeotropic distillation, and reactive distillation. Besides the traditional thermodynamic model, RadFrac can be extended to include analysis of column hydraulics, where sizing and rating of the column is performed. RadFrac assumes total equilibrium on each separation stage. Stage efficiencies are introduced to capture the non-ideal separation, which is typical for actual column operation. To represent the real equipment, we need to convert theoretical stages into actual stages. The new RadFrac stage number input can be computed using theoretical trays divided by efficiency plus 2. 2 represents, where applicable, the reboiler and condenser, because efficiency of the condenser and reboiler should always be 1. Stage efficiencies can be specified on the vapor-liquid sheet in RadFrac under Specifications, Efficiencies. 2 efficiencies are available in Aspen Plus: vaporization efficiencies and Murphy efficiencies. When converting from theoretical trays to actual stages, Murphy efficiencies are preferred since vaporization efficiencies may impact the temperature profile and thus alter relative volatilities. Unspecified stages and efficiencies are interpolated from specified values. To rigorously calculate efficiency, the rate-based option in RadFrac is required. Otherwise, efficiencies are specified by users. A starting point for efficiencies is to assume that each stage's efficiency is equal to the required number of theoretical trays for the desired separation divided by the number of actual stages. During a design phase, using a value of 0.7 or 70% is typical for designers. Once efficiencies are provided, the new column analysis feature can be utilized. Column hydraulic analysis in Aspen Plus has an improved user interface and calculations for evaluating trade and packed column performance. It incorporates interactive design and rating for most common trays and packings, and has detailed hydraulic operability plots to provide visual insights into column performance. Column hydraulic analysis divides the column into sections. Each section can have a different internal type and geometry. Calculations are based on vendor or literature procedures depending on the selected internal type. Users can find more details on our improved calculation methods and empirical correlation in our validation white paper. The new column hydraulic analysis tool embeds design advice that gives suggestions to resolve hydraulic issues. This demo performs efficiency setting of RadFrac on an HCl column to understand how to convert a theoretical column into an actual column. The feed stream includes components HCl, VCM, and EDC. HCl is separated by distillation. The case is set up with full equilibrium stages and results are available to view. Double-click the column, navigate to the results sheet, record column condenser and reboiler duties as base data. To rate the column tray performance properly, we need to enter the actual number of trays as stages and implement stage efficiencies for the trays. We will assume that each tray is 50% efficient, so the current 35 stages, including 33 column stages, condenser, and reboiler, should be increased to 68 stages, which comes from 33 divided by 0.5 plus condenser and reboiler. On the stream sheet, change the feed location for feed A to stage 35, corresponding to the total stage changes. On the pressure sheet, change the pressure for stage 35 to stage 68. Now let's set the tray efficiency. On the Specifications Efficiencies sheet, select Murphy Efficiencies. Then on the Vapor Liquid sheet, enter 0.5 for all the stages representing trays except the condenser and reboiler, which are assumed to be in equilibrium. Reinitialize and run the simulation. Check key results at the results sheet. The values should be close to the original base case, assuming full equilibrium stages. With hydraulic data available for each tray, now we can perform column hydraulic analysis. On the HCl/COL block, Specifications Configuration sheet, click Design and Specify Column Internals. Click Generate to calculate hydraulic data. Click Auto Section to divide column into sections based on flow rates. Let's view the hydraulic operability plots. The stage design using the default setting shows warning and error messages. These messages will be addressed in the next topic.